48 gave us these integrals that were set up to start with. Me too, Penny. There was only 2 multiple choice, yeah. Nope.
I'm getting really angry about this whole door situation.
There's a big yellow sign on it, walk around. And all day long, bam, bam, bam. Well, because theoretically, if you have to go through the weapons detector here, they could come up those stairs, come up here, and come in that door. So she wants these doors to stay locked. It does. Yep. I agree. Wholeheartedly. I'm giving this.
It's like it could actually happen.
Oh, we started because the door was somebody was banging on the door.
Because you went out there trying to, and then I was like, yeah.
All right, so given this information, which of the following must be true except? So we're looking for the exception to the rule, not the rule itself. So the first one says that the integral from 2 to 5, and these are all f's, I'm not going to rewrite them, minus from 5 to 8 must be 0. 3 times. So that would be 2 to 5. That would be 12 minus, the point of this one, this is number 48. The point of this one is that you know that 3 can come out, right? So it's 3 times this 5 to 8, which is 12. Well, yeah, that's got to be 0. Oh, 4. My brain's getting ahead of me. So A doesn't work because A is true. A has to be true. So then we move on to B. Does B have to be true? B says the integral from 5 to 2 is negative 12. Well, yeah, because if I switch up those bounds, all it does is switch up that sign, right? So that has to be true. So then I move on to C. C says the integral from negative 5 to negative 8 is negative 4. So they threw a negative sign in front of each one of those bounds and then just changed the sign of that, and you can't do that.
Oh, okay. I wouldn't, because there's no limit.
Right. So, okay, so D says from 2 to 6 plus from 6 to 8. So what I can do is I can combine that and say, well, that's the same thing as from 2 to 8. And I have from 2 to 5 and then from 5 to 8. So I could add those two together to get 16. It doesn't matter how I split it. I'm still covering that entire bound. Like what? So 6 goes from negative 1 to 1, h of r. And this one might have been confusing because they might have switched it up. And when they switched it up, it looked like it changed signs, but I don't know. Let me just shut up and look at it again. So not this one or yes, this one. How about 6 and 4? So this one, the first thing it asked me to find was from 1 to 3 of h of r dr, right? So here's how I have to think about this. This one, and I'm on a number line here just so I can picture, here's 0. I'm going from negative 1 to 1. So this is this one is going here. The second one is going from negative 1 to 3. So this one is asking me from 1 to 3. So this one's asking me for this area right here. Well, if I take that whole blue area and I subtract out that pink area, it'll leave me this, right? Okay.
You're at one to negative. Yeah, I'm wondering how, I mean, I know I told you that.
That's okay.
Number 4, is that one?
Okay, so 4 started out like this, right? And then they said, what is this? So what happened here? Just flip the bounds. Okay. You might have just glanced at it wrong. It might have looked like they were doing something that they weren't. Anything else? Anybody else? All right, let's look at the new stuff. I'm going to show you 2 things in order to do average value today. I'm going to show you the thing you need, and you're going to see it's really easy, actually. And then I'm going to show you, and I might even show you how to do it on calculator, because it's really easy. Okay. Let's talk about antiderivatives a minute first. Well, antiderivatives for this part, and then the second part's average value. We have, but we're going to do antiderivatives in relation to integrals. We'll say antiderivatives evaluating a definite integral. What's a definite integral? What we just did. It's definite because it has endpoints on it. We'll do some where they don't have the endpoints, and that's where we'll have to do the little plus b for the antiderivative. But because there's endpoints, it's defined within a certain interval. Let's say I have this. Now, what you've been doing is you've been graphing this function and looking at a shape, trying to find the area of the shape, right? Whether it's a triangle, a trapezoid, a square, a rectangle, whatever it is. And then you find the area that way, right? That only works sometimes, though, right? Because if I graph this, this is a quadratic, and it's just a parent, something like this. And this is asking me to find the area under the curve from 1 to 2. Which is all of this. That's not a shape I know. That's not a shape I can find, right? So geometry's out the window for that problem. So what I have to do is I have to back up and think, okay, well, what in the world am I going to do to evaluate it? So what I have to do, remember, this is just the backwards of derivatives, right? So if I can identify the antiderivative of this, let's say f of x is x squared, then if I could find the antiderivative, remember that capital F means antiderivative, and what I'm going to do is I am going to evaluate it between 1 and 2. In other words, plug in 2 and plug in 1 and find the difference of the two. This is a big, 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 big concept for calculus, but it's not a hard one. So all we do, antiderivative, and then we do the antiderivative at the upper bound, the antiderivative at the lower bound, and we subtract the two. You can, as long as you can find the antiderivative of it. Like if I had something like the square root of 9 minus x squared. Remember that was that semicircle? I have no idea what the antiderivative of 9 minus x squared is, right? Because I would be into chain rule and stuff like that. Square root 9 minus x squared. So I could use shapes for that. But 9 times out of 10 you can, and I'm going to show you how the calculator will do it for you too. But let's do this one together. What's the antiderivative of x squared? How do we find you found derivative. Go backwards with that. So add 1 to the exponent, right? Remember that? So if I found the derivative of that, would I be back to x squared? All right, y'all all with me? All right. So now really what I'm doing is I am taking 1/3 x cubed and I'm evaluating between 2 and 1. So I would do 1/3 times 2 cubed minus 1/3 times 1 cubed. Plug it in and find that value. I actually much prefer this to the geometry. And we will, yes, you always subtract with your bounds. You always do upper bound minus lower bound. Yeah, I'm sure there is. I don't know. That's it. That's it. That's the area. So the area, whereas before, remember we were breaking it up and finding, oh, this is 2 trapezoids put together, or a rectangle and a triangle, or this. Instead of doing all that, we've just done it algebraically instead of geometrically and found that it's 7/3 for that. It's easier, harder? Yes. So this is a more exact way of RAM. But you still have to. RAM's a huge concept. Definitely takes probably an effort. I don't know, but it is. Let's do another. Well, you're going to use this to do average value. So let me make sure you got this. What if I asked you to evaluate I'll give you a second. All right. That's crazy, you think? I would probably write it like that to help me a little bit. This, by the way, is part of number 12. That's why I chose it. It's the upper bound minus lower bound once you find the antiderivative. Yes. You add 1 to it, and then you divide by that. She was saying, do you divide this by 2 or do you add 1 first and then divide by 3? You add it and then by a third. Now, if I'm doing this problem, I'm pulling this negative out first, probably. I'm saying that this is, don't have to. And in fact, I could also pull out you should get one specific value. I find that easier if I'm working this problem. I'd rather find the antiderivative of x squared than negative 1/2 x squared. Do you remember that coefficient rule? If it's got a coefficient, I can just plop it outside. Now, if you did it using that one, it's not wrong. It's okay. I would do it this way, and then I would say my antiderivative, so I've got negative 1/2, and that's going to multiply by everything, right, whenever I'm done. My antiderivative for x squared, I'm going to have negative 1/3 x cubed, and I'm going to evaluate that from 0 to 3. So the negative 1/2 still sits outside because I got to take that to the whole thing. I pulled it outside. And now I've got 1/3 times 3 cubed minus 1/3 times 0 cubed. That'd just be 9. Whichever way you did it. Yeah, no, that's fine. That's fine. What do you think about the antiderivatives and evaluating? You can find an antiderivative, it's easy. Okay.
Oh,
Yeah.
I did it as 9 divided by
I gotcha. Let me show you on your calculator just quickly before I show you average value, just so you know, so you have this tool to use. If you will put the function into y1 just like we did before. So, and I would put the whole thing, I wouldn't try to take anything out or anything like that. I'd put this whole thing. Negative x squared, no parentheses on this, over 2. Now there's 2 ways to do this. This is so much fun to me. I prefer the graphing, it takes a little bit longer, but just to show you. I like the graphing way because it's a visual thing. If you hit Zoom 6 so that you can actually see that parabola. You see why we're getting a negative number now? It's below the axis. All right, so I want you to hit second trace for calculate. And look at option number 7. That's an integral. Lower limit, 0. Upper limit, 3. And hit enter. How's yours work? Mine just yeah. Because I went 0 to 3 on my integral. But isn't that cool? And it's shaded like that for you. So you see the shading and you see, and it's the answer. No, I like it too. I like the graphing. Now, you can also do it where if you come out of here, remember you're still in Y1, right? Hit math and go down to 9. So instead of 8 for derivative, you're in 9 for integral. And this is where everything's going to be the same as whenever we did the derivative. So we're going to tell it to pull up Y1. What does y'all look like whenever you push number 9? Is it an integral? Oh, then you can just type in and you put Y1. Well, you already put, bars. Now, if you've got an older calculator like mine, yours isn't going to look quite like theirs. Theirs is going to look exactly like this. Bars, function, Y1. For those of you with the older calculators, you've got integral, you're going to go function, or you're going to go vars, and you're going to choose Y1, and then comma X, and then comma, do your lower bound and your upper bound. So 0, comma. Average value. But I wanted to show you how to do it on your calculator so you can go back and check that stuff. It didn't work? You gotta put X in there. You gotta tell it what variable you're doing it with respect to. That's your DX. So if it was whatever. So we do all that. Part goes. Yay, you just learned the whole base concept for the whole second half of calculus. Like if you didn't take that, okay, so if it was negative 1/2 x squared, because I'd write it like that, add 1, that would be 3, right? So then you've got negative 1/2 times 1/3, is that 3, is x cubed, which would be negative 1/6. All right, average value of a function, and then I'll stop. I'm done. We'll be ready for fundamental theorem when we come back. Yay. The average value of a function, this is just something you just have to remember. It pops up a lot though. Remember when I told you we'd come back to this, put a pin in it, we'll come back to it because we were talking about average value and y'all were finding like the value at this point and the value of this point and you were adding them together and dividing by 2 and I told you we'd learn a little bit quicker way to, well, anyway, we're here. If you don't remember, that's okay. If I have a function f of x, to find the average value of that function over an interval, let's say AB. In fact, I think we were doing average velocity. To find the average value, we do 1 over b minus a, and then we multiply by the integral from a to b. That's it. That's average value. Yeah. You'll get better at it. Yeah. Yeah. Whatever. We know what you're talking about. And then come back and do them. Let's do an example and then I'll stop. If f of x is 4 minus x squared, find the average value on the interval 0 to 3. You do have the antiderivative. Right.
So it's 1 over the antiderivative of
What? So it's we're gonna do 1/3. Okay. Yes. Yes. What's the antiderivative of 4? 4x. Remember, what's the antiderivative of x squared? 1/3. You got to retrain your brain from doing derivative to antiderivative. But that's being evaluated from 0 to 3. So you only do plus c's when we do indefinite integrals, and we'll do a whole unit on indefinite integrals. But for definite, you don't have to do the plus c because of the bounds here. Good question, though. I got 4 times 3 minus 1/3 times 3 cubed minus 4 times 0 minus 1/3. And of course, you don't have to write all this. I just really wanted you to see where everything was coming from. Upper bound minus lower bound, I just plugged in. Bless you. 1/3. 12 minus, what is that, 9 again? So all that, and you get 1. Not for right now. For right now, that's as hard as I want to go with it. But don't you worry, my little friend. It will definitely get harder. This is what I couldn't decide if I was just going to show you how to do the integral on the calculator or by hand to do average value, because really average value should be with the unit in my opinion, but the next half of it. Yeah, that's all I got for you. So let me tell you what I want you to do. What time is it? Shut up! Yeah. Okay, well, let's see how the quiz grades are, and then we'll see if that's how it really needs to be. We'll see if y'all are being successful with that way.